Let's find the derivative of f. The derivative of e to the x is simply e to the x. And the derivative of 3x squared, we'll use the constant multiple rule. We bring down the 2 to get 2 times 3 is 6, and subtract 1 from the 2 to get 6x. In this example, we have a quotient. Now, if you know the quotient rule, you're welcome to use it, but we haven't learned it yet, so we need to rewrite this in a form that we can differentiate. So let's first start by splitting apart the fraction. From here, we can simplify each of those terms. In the first one, we get 1 over x to the 3 halves. And then the second one, we get 1 over x. We get x to the negative 3 halves plus x to the negative 1. So now, f prime, looking at this first term here, we bring down the exponent, negative 3 halves, x to the subtract 1 from the power. So negative 3 halves minus 1 is negative 5 halves. And then looking at our next term, bring down the negative 1 and subtract 1 from the power, we get x to the negative 2. Let's keep simplifying to remove the negative powers. In our first term, we get negative 3 over 2 square root of x to the 5th. And our second term, we get negative 1 over x squared. And we have f prime. Notice G is a product. If you know the product rule already, you're welcome to use it, but we haven't learned it yet. So we need to first rewrite this in a manner that will allow us to use the constant multiple rule that we do know. So we'll FOIL this, giving us 3n squared plus 6n minus n minus 2. Combining like terms, we get 3n squared plus 5n minus 2. Now that it looks like a polynomial, we can use the constant multiple rule. We get 6n plus 5 as g prime.